This is TechCrunch. Nuclear startup X Energy began its investor roadshow on Wednesday as it works toward its IPO, setting its target price between $16 and $19 per share. That's according to documents filed with the U.S. Securities and Exchange Commission. If it lists at the higher end, the startup could net about $814 million. X Energy and its peers have been riding a renewed wave of interest in fission power as demand for electricity has surged on the back of AI data centers and society-wide electrification. Amazon is one of X Energy's biggest backers. The tech giant led a $500 million Series C1 round and has pledged to buy as much as 5 gigawatts of nuclear power from the company by 2039. The IPO is sure to come as a relief to X Energy's investors, which have put about $1.8 billion into the company. That's according to PitchBook. The startup had previously attempted to go public via reverse merger with a special purpose acquisition company, but the two parties canceled that deal in 2023 as the SPAC craze petered out. X Energy's reactor is what's known as a high-temperature gas-cooled reactor. Inside, uranium encased in spheres of ceramic and carbon is cooled by helium gas. The gas then transfers heat to a steam turbine loop to generate electricity. The fuel design, known as TRISO, is expected to be safer than previous fuel arrangements, though it's not widely used today. The startup said in its SEC filing that it's already embroiled in a patent dispute with another company that recently went bankrupt. Ultra Safe Nuclear Corporation went bankrupt in 2024, and its assets were purchased in bankruptcy to form Standard Nuclear. X Energy alleges that USNC infringed on its fuel fabrication patents and that the matter has not been resolved to its satisfaction during the course of the bankruptcy proceedings. Outside of China, development of new nuclear reactors has all but stalled, stymied by delays and cost overruns. A new breed of startups hopes that by shrinking reactors, they'll be able to overcome some of the challenges that have beset traditional designs. None of the small modular reactor startups have built a power plant yet, though several are racing to meet a deadline of July 4th set by the Trump administration. While many might miss the arbitrary deadline, they're still likely to achieve criticality. That's the moment when fission reactions become self-sustaining. But the road from criticality to profitable power plants is likely to be a long one. Mass manufacturing can help bring costs down, but it usually takes around a decade for the process to start paying dividends. What's more, the number of reactors these companies are planning to build might be more than any other companies have attempted, but it might not be high enough to reap the true benefits of mass manufacturing. X Energy expects that by the time its reactor production techniques are mature, what experts call nth of a kind, it will be able to bring costs down by 30% relative to the first of a kind. Investors should pay close attention to how much that first reactor costs. It could make or break the company's prospects. The promise of physical AI is that engineers will be able to program physical agents the same way they do digital ones. We're not there yet. Robotics is still held back by a paucity of data from physical spaces. To train their machines, companies need to build mock-up warehouses to test their machines, while an entire industry is springing up around surveilling factory lines and gig workers to train deep learning models to operate robots. Another option is simulation. Detailed virtual replicas of real-world environments could provide the data and workspaces that roboticists need to do this work in a scalable way. Antioch, a startup building simulation tools for robot developers, wants to close what the industry calls the sim-to-real gap, the challenge of making virtual environments realistic enough that robots trained inside them can operate reliably in the physical world. Antioch co-founder Harry Millsap asked, "How can we do the best possible job reducing that gap to make simulation feel just like the real world from the perspective of your autonomous system?" Millsap started the New York-based company with 4 co-founders back in May of last year Two of the other founders, Alex Langsher and Michael Calvey, joined him to co-found Transpose, a security and intelligence startup, and sell it to Chainalysis for an undisclosed amount. The other two, Colin Schlager and Colton Swingle, previously worked at Meta Reality Labs and Google DeepMind, respectively. The need for better simulation is at the heart of what many major autonomy companies are doing. In the self-driving car space, for example, Waymo uses Google DeepMind's world model to test and evaluate its driving model. In theory, that technique will make deploying Waymo vehicles in new areas require less data collection, a key cost in scaling up autonomous vehicle technology. Building and using those models to test robots is arguably a different set of skills than creating a self-driving car, and Antioch wants to build the platform that solves that problem for newer companies without the capital to do it all themselves. Those smaller companies also don't have the capital to build physical testing arenas or drive sensor-studded cars for a few million miles. Millsap said, "The vast majority of the industry does not use simulation whatsoever, and I think we're now just really understanding clearly that we need to move faster." Antioch executives compare their product to Cursor, the popular AI-powered software development tool. Antioch allows robot builders to spin up multiple digital instances of their hardware and connect them to simulated sensors that mimic the same data the robot's software would receive in the real world. These environments allow developers to test edge cases, perform reinforcement learning, or generate new training data. If, that is, the simulation is sufficiently high fidelity. The challenge here is making sure the physics in the simulation matches reality, so that when the model is put in charge of a real machine, nothing goes wrong. The company starts with models built by NVIDIA, World Labs, and others, and builds domain-specific libraries to make them easy to use. Working with multiple customers, executives say, gives Antioch a depth of context for refining its simulations that no single physical AI company could match on its own. Antioch's focus now is mainly on sensor and perception systems, which account for the bulk of the need in automated cars and trucks, farm and construction machinery, or aerial drones. Aspirations for physical AI to power generalized robots to replicate human tasks are further away. While Antioch's pitch is to startups, some of its earliest engagements have been with huge multinationals that are already investing heavily in robotics. That's all for now. For more stories like these, go to TechCrunch.com.